Hi friends, welcome to follow up. Let's have a look at problem 2839. Check if strings can be made equal with operations. This is the first one. So here we are given two strings, S1 and S2, both of length 4, consisting of lowercase English letters. So we can apply the following operation on any of the two strings any number of times. So we choose any two indices ij such that their difference is 2, and then we swap the two characters at those indices in the string. So we want to check if we can make the two strings S1 and S2 equal. So here we have two examples. So in the first one, so if we reverse the first and the index 0 and index 2 characters, so we're going to get these two strings the same, so we return true. And in the second one, so we have A, B, C, D and D, A, C, B. So notice that here A in the first string appears at index 0, and in the second one it appears at index 1. So index 0 and index 1 actually can never have a difference by 1. So it's impossible for the two strings to be equal. So before we look at code, let's look at constraints. So here the constraints actually are stated in the main problem statement, so we are not going to read them. So here the operation is that the index difference is 2. In other words, so you can reverse the odd indices or reverse the even indices. Actually, the indices are grouped into two, right? Odd indices and the even indices. So with that said, basically, we can do the coding. So this problem is not about coding in a sense. Basically, we need at most two swaps or two such operations to get the result. Let's write a code and then explain the logic. So first, I'm going to change this to string to list. So this is just the type conversion. So because this string is immutable and list is mutable, so with working with mutable objects here bring us some convenience. So first, if S1 0 and S2 0 does not equal, so in this case we need to do a swap, right, to check if we can make them equal. So in this case, let's do it on string 1. So you can do it on string 2, but work with a consistent manner. So S1 not S1 2, right? So we're going to reverse this swap this 2. So this is S1 and 0, S1 2, S1 0, right? So this way we did this reverse. So in this case, we try to fix the first index. So let's do a check. If S1 not does not equal to S2 not, even after this swap, then we can directly return false, right? Otherwise, so this index at index 0 are now equal. Then we need to check the index 2, right? So if S1 2 does not equal to S2 2, so in this case we are ready to return false also. And otherwise, so it means that for the two strings we can make them equal at even indices. Now let's check odd indices. So first, if we check, actually it's repeat the procedure, right? If S1 1 does not equal to S2 1, so let's first make a swap. So S1 1, S1 3, right, equals S1 3, S1 1. After this swap, let's do a check again. Same logic as above. So if S1 1 does not equal to S2 1, in other words, after this swap or operation, we can still not make the two positions equal, so we are going to return false directly. Otherwise, so this position are made equal, and then we check the last one. So we just need to return if s1 3 equals s2 3, right? So this will be the logic. Basically, this are like plain English, right? So before we make any comments, let's first do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes the generic cases. So here we want to make a comment or as an extension, right? So extension, right? So we can assume that this operation is like this: choose any two indices ij such that j minus I equals 2, and then swap the two indices. So here in this problem, it's very special. S1 and S2 both have length 4. So what about what if we drop the length 4 assumption? So in other words, we assume S1 and S2 have same length, but the length can be large. So in this case, how to solve this problem? So this is actually a very natural extension. So if you have comments or some thought, you're welcome to add at the comment section. So with that said, that's about it for this video. Thank you.